So question number 5 is 2009, question 4. One of the 2 fire stations in a certain town responds to calls in the northern half of the town, and the other fire stations responds to calls in the southern half of the town. One of the town council members believes that the 2 fire stations have different mean response times. Response time is measured by the difference between the time of an emergency call comes into the fire station and the time the first fire truck arrives at the scene of the fire. Data were collected to investigate whether the council member's belief is correct. A random sample of 50 calls selected from the northern fire station had a mean response time, here's a key word, mean response time of 4.3 with a standard deviation of 3.7. That is really important information. As soon as they tell me I have a mean and a standard deviation, it's like, all right, I'm working with a sample of means because this came from a sample, because it came from a sample, that lets me know I'm working with a t-test. So we have a random sample of 50 calls selected from the southern fire station, had a mean of 5.3 and a standard deviation of 3.2. So I have 2 samples. I have summary statistics from 2 samples. So that lets me know I'm working with a t-statistic for 2 samples. And then in the next part, they say construct and interpret a 95% confidence interval for the difference in mean response times. Well, there's that, all I needed to know. I know it's not a hypothesis test. They specifically asked for a confidence interval. Once again, I'm not required to do this, but I have 2 means, so I'm going to go ahead and set, hey, this is what be if they're equal. And because I'm working with a confidence interval, I know it's 2 tails, so not equal would apply. So mu1 equals the true population mean response time for the northern fire station, and mu2 equals the true population mean response time for the southern fire station. Conditions: 2 independent random samples of 50. That was given. Notice I combined independent and random together. All right, that just speeds things up. N is less than 10% of the population for each. Each station has at least 500 calls, and I showed that by 50 divided by 0.1. You need to show your math. You can't just make the statement, so make sure you do that. Whether you do 50 times 10 or 50 divided by 0.1 is up to you. N1 is 50, N2 is 50, so N is greater than 30 for both samples. That's really important because they didn't tell me the shape of the underlying distribution. And so I can now say it's normal by central limit theorem. And remember, both samples must be 30 or larger. For normality for a test of means, you have a couple different ways. The underlying distribution could be normal, in which case you're good. Normal by central limit theorem, which is what we have here, or they give you data and you'll have to graph it to see that it's not unreasonable to assume that it's normal. All right, so one of those 3 will take care of that condition. So we have our formula, the difference in means, plus or minus. This is a t-star, and the reason it's a t-star is because we're working with the standard deviation of the sample. All right, and we need to write down there the degrees of freedom. And you're like, well, where did that number come from? That number came from the calculator. So while it's not really intuitive, we're going to run the test, and we're going to completely run the test and get our interval, and then we're going to go back and calculate our t-star. So with that said, stat test 2 sample t-test, and we're working with statistics. We're not working with data. We don't have a list of data points. And our first one had a mean response time of 4.3 with a standard deviation of 3.7. Our second, and a sample size 50. Our next one was also sample size 50, but it had a 5.3 minute response time with a standard deviation of 3.2, sample size 50. And we're looking to see, because it's, you know what, I did it again. It's not a 2 sample t-test. I'm trying to run that 2 sample t interval. All right, so 2 sample t interval. We got everything entered, and I need to change that confidence level to a 95% confidence level, so 0.95. When we're working with means, we never pool. So we're going to go ahead and calculate. And this is where I got my degrees of freedom of 96, so I'm going to write that down. I'm going to go ahead and write down my interval, which is negative 2.373 to 0.373. And now I need to go back and calculate that T star, and I have to show them where I got that. All right? So stat, second quit, second vars, inverse T. In this case, 1 minus 0.95 because it's 95% divided by 2 for the two tails. Degrees of freedom, we got that from the calculator, which was 96. And we end up getting about 1.985. So that's where that came from. So the conclusion, we are 95% confident the true difference in mean response times between the northern and southern station lies within this interval. Great. That takes care of that first part. Does the confidence interval in part A support the council members' belief that the two fire stations have different response times? Explain. I need to make sure I answer the question. The question was, does it support the claim? Well, the claim was that there is a difference. So the above confidence interval does not support the council member's claim. There it is. I answered their question. Next part, I must always justify it, regardless whether they asked it or not. And sometimes they neglect to ask it. I must always explain. And in this case, the 95% confidence interval contains 0, which means that there is not sufficient evidence to suggest there is a difference in mean response times between the two stations. And that